Alright, in this video we're going to talk about Unit 9, Objective 1, slope fields. And what a slope field is going to do is it's going to show us every possible function with a given slope. So what we mean by that is if I give you the slope, let's say dy dx equals 1/2 x. Now when we're dealing with slope fields we generally use the dy dx notation for derivative. So dy dx equals 1/2 x. So I have some function, its derivative is 1/2 x. If I want to know what that function is, we could take the antiderivative of 1/2 x with respect to x, and we're going to end up at 1/4 x squared plus c. So there are infinitely many possibilities that we could have for a function whose slope is 1/2 x. We could have 1/4 x squared, 1/4 x squared plus 1, 1/4 x squared minus 12. Any value we can put in for c is going to give us a function whose derivative is 1/2. So what a slope field is going to do is it's going to help us picture all these possible things. So let's take a look at what a slope field would look like. So one thing that I want to change on this little diagram, you'll notice it says y prime. I'm going to change that to say dy dx because that's generally how we are going to call this thing, or what we're going to call this thing. So dy dx equals 0.5x. You don't really need to worry about this thing here either. We just need to think about dy dx equals 0.5x. So how we are going to construct our slope fields is we are going to take our dy dx and we're going to evaluate it at any number of points that we decide to evaluate at. So let's start with a really easy point, 0, 0. So I have an x value 0, I have a y value 0. I want to put those values into my slope. So I have 1/2 times plug 0 in for x. There's nowhere to plug y in, so we just simplify it from there and we know 0. 1/2 times 0 is 0. So what we just found is the slope at the point 0, 0 is going to be 0. So what we're going to do is we're going to go over to our graph and we're going to make what's called an isocline, I-S-O-C-L-I-N-E. And what that is just a little tick mark that has the slope that we just found. So at 0, 0 we found a slope of 0. A slope of 0 looks like that. Then all we have to do is pick another point. So let's try 1, 0. So dy dx evaluated at 1, 0. That's going to be 1/2 times 1. Again, there's nowhere to plug y in, so we're going to get a slope of 1/2. Now when we're doing this with AP, we don't have to be super accurate, but we do have to make sure our slopes of 1 are not the same as our slopes of 1/2. So if we're looking at it, a slope of 1 Sorry about that. A slope of 1/2 is going to look different than a slope of 1. So a slope of 1 generally is going to connect 2 points. So if we just make it a little bit less steep, we can say something like that would be a slope of 1/2. So the point 1, 0 is going to have a slope of 1/2. Now on AP, they're generally going to say make the slope field at the given 12 points, and there'll be little dots on the graph that they want you to find them, and we're just going to have to do that 12 times. Take your x value, plug it into your dy dx, take your y value, plug it into your dy dx, find your slope, make a little isocline. So if we were to go through this a whole bunch of times, we could make a pretty good slope field that would look like that. So if you notice right here, we have that slope of 0 that we found a second ago. Let's actually do it this way. We have that slope of 0 that we just found. We have at 1 a slope of 1/2. If we go over to 2, we would get a slope of 1. And you can just pick any point. If you pick the point 1, 2, 1 goes in, 1/2 is going to come out, so you notice you have a slope of 1/2 right there also. One thing I want to point out is if you look at your derivative, 1/2 x, there's no y value. Now, looking at your slope field, you will notice that all of the isoclines at a given x value are the same. So if you look at all of the isoclines when x equals 0, they're all 0. If you look at all of the isoclines when x equals 1, they're all 1/2. If you look when x equals 2, they're all going to be 1. If you notice a pattern on x values, then you know that there's no y in your slope field, or I'm sorry, in your derivative. It's just going to be in terms of x. So if we have a slope field whose patterns, isoclines, have a pattern at on the y values, we know there's not going to be an x. So I'll show you what that looks like real quick. So you'll notice I changed the dy dx to 1/2 y. So you would come up with these things the same way. We would say dy dx evaluated at 0, 0. We would put 0 in for y this time, so 1/2 comma 0, I'm sorry, 1/2 times 0 is 0. And if you look at the point 0, 0, we still have an isocline, we still have a slope of 0. But now if we go and say dy dx at the point 1, 0, remember last time we had a slope of 1/2, well this time we have 1/2 times y. Y is 0, so we still get a slope of 0 for our isocline. Now, like I was mentioning earlier, if you notice, all of your isoclines stay the same at each y value. So y equals 2, all of those have a slope of 1. Y equals -2, all of those have a slope of -2. So if you see a pattern going across your y values, you know your slope is going to be in terms of just y. There's not going to be any x involved there. Now, those ones are pretty easy. Sometimes we get tricky ones that have both x and y. So let's take a look at one of those. Alright, so you'll notice I've changed dy dx to be x plus y, and our slope field on the right has changed. So again, if we were to have to make that by hand, which you might have to do on the AP exam, we would simply take a point. So we can say, we'll start with 0, 0. So dy dx evaluated at 0, 0 would equal 0 for x plus 0 for y equals 0 overall. And if you look at 0, 0, our isocline right there has a slope of 0. We could take the point, let's go with 1, 1. So dy dx evaluated at the point 1, 1 would be 1 plus 1, which is 2. So if we look at the point 1, 1, its isocline has a slope of 2. So again, AP will give us 9 points, 12 points that we want to look at. We'll plug in the x value and y value into the slope, draw our isoclines, and we will be finished as far as that goes. Now, there's one more thing that AP can ask us to do. They can ask us to draw a particular solution. So this shows every solution. We can come up with the particular solution. So what they can say is sketch the curve with dy dx equals x plus y that goes through the point 1, 1. So what we want to do is, first and foremost, if they tell us we have to go through the point 1, 1, we're going to draw a dot at 1, 1. Then we want to kind of stay in between the isoclines, but have them show us what we need to do. So this isocline's going like this, so I'm going to continue tracing down this way. Now our isoclines kind of start to level out a little bit. Then we go at 0, then we start to come up this way. And when we're drawing these, we don't ever want to cross an isocline. So we're going to stay in between all of those things. Oh, and I just crossed them. You can go in between them, but you don't want to touch them. So we're going to get something that looks like that. Now, AP is not going to be super critical and say, well, you should have passed through these isoclines, not these isoclines. As long as you have the general shape that the isoclines are telling you, you're going to be okay. The two things that you must make sure you do, though, is you have to hit the point that they tell you, and you have to extend your graph all the way to the end. So you can't stop and draw your little arrow here and draw your arrow here. You're not going to get credit. You have to extend it to the end of the graph. So that's going to do it for this video. We will see you in the next one.